All right, we are working our way through complex numbers. All right, so let's do some adding, subtracting, and multiplying. In general, I think you guys are going to find this stuff not too difficult. All right, when adding or subtracting complex numbers, the key is to add and subtract the real parts, and then add or subtract the imaginary parts. All right, so for example, what do I mean? Given two complex numbers, like a plus bi plus c plus di, so we have our two numbers, I'm going to add the real parts together, the a and the c, and then I'm going to add the b and the d, or the imaginary parts, together. Same thing when subtracting. I'm going to subtract the real parts, a and c, and I'm going to subtract the imaginary parts, b and d. All right, let's go through a few examples with numbers, all right, because I suspect you guys are relating to my cartoon over here on the right. All right, let's find the sum of these two complex numbers. Okay, now keep in mind the real parts are 3 and negative 2, so I can add them together. My imaginary parts are negative 4 and 6, and I'm going to add them together. All right, and so I end up with 1 plus 2i, final answer. All right, so again, 1 plus 2i. All right, let's find the difference. All right, so I'm going to subtract the real parts. The real parts are the negative 4 and the negative 6. So I subtract negative 4 minus 6, and I subtract the imaginary parts, 3 minus negative 7. All right, that's going to give me negative 10 plus 10i. Right, how do I get 10 on the imaginary part? Well, note that we have 3 minus negative 7, so the two negatives make a positive, and I end up with the 3 plus 7. All right, what about multiplying complex numbers? All right, you guys grew up hearing the acronym FOIL, and we're basically going to use FOIL when we want to multiply two complex numbers. And you guys got to keep in mind that anytime you see an I squared, you have to substitute it for negative 1. You will never, ever, ever leave a final answer with I squared in it. All right, that's a big old hint for the exam. So I'm going to go through it once with all the A's, the B's, and the C's. All right, just bear with me or fast forward, and then I'll work one or two with some numbers. All right, so we've got two complex numbers here. All right, and note I'm going to FOIL them. All right, I don't like FOIL because technically it's just double distribution. Note I write my A, and I write the other complex number. I take this sign right here, which is addition. I write my imaginary part, bi, and I'm going to multiply it with the other complex number. I think it's a lot easier to think of distribution this way than getting lost in the first, outer, inner, last. All right? All right, now you can see how I distribute my A. So I get AC, and I distribute the A to the imaginary part to get ADI, and I distribute my BI term. All right, and here I get B times D, and then I get two i's multiplied together, which gives me the I squared. All right, I can combine my like terms in the middle, all right, and then on the end here, I'm going to substitute I squared for negative 1. Okay, so keep in mind, guys, I squared is negative 1. You'll hear me say it a gazillion million times over the next week. All right, and then lastly, I just combine my like terms. I have two terms without an I have two terms with an I. Okay, so again, do you have to memorize this? Absolutely not. I'm just trying to help you see that FOIL is just a special double distribution to make sure you don't leave I squared in your answer, and to realize that when we multiply two complex numbers, it's something we've been doing for a long time. All right, so let's find the product of these two complex numbers. Again, we're going to FOIL, or double distribution. I take my 2 multiplied by the 3, and let me grab my pen so you guys can follow me. I do the first 2 times 3, then I do 2 times 4i, then I do negative 3i times 3, and then I do negative 3i times 4i. And now I've multiplied it. I just have to do a little bit of algebra to clean it up. All right, first term is a 6. All right, again, let me grab my pen here. First term is a 6. 2 times 4i is 8i. Negative 3i times 3 is negative 9i. And then here I'm getting negative 12 and an I squared. Now am I done? And hopefully you're all shaking your head going, heck no, you're not done, because we still have an I squared, and I have two I terms I can combine. All right, so I'm substituting I squared for negative 1, and I'm combining 8i minus 9i, And my final answer here is 18 minus I. All right, again, how am I getting positive 18? I'm getting positive 18 by the fact this becomes a positive 12, and I have 6 over here. I can add them to get my positive 18. All right, what happens when it's written this way? A parentheses with a square. All right, the first key is to write the parentheses twice. All right, and so usually when this happens, your brain says, oops, I think I'm going to have to FOIL this. All right, and so that is our first step. We're going to FOIL this identical parentheses. Okay, just like we did in the last slide. After FOILing, I'm going to start trying to clean it up. All right, note I have a 4 squared, which is 16. Again, let me grab my pen. 4 squared, which is 16. This gives me 12i. This gives me 12i. So I can add them together to get 24i. And then over here I have 3 times I, which is 9i squared. As you guys know by now, we don't leave it as I squared. We substitute I squared for -1. And then I simply combine the 16 and the -9 to get 7. Final answer, 7 plus 24i.